Let's take a look at this example a little closer. Now from our graph, we have the points, -4, -3. -2, 0. 0, 3. 2, 0. And 4, -3. And they're telling us we got y is equal to f of x, and g of x is equal to 4 minus 3 f of 1 minus 2x over 2. Okay. Now, here we got f of x, and over here we have f of 1 minus 2x. So let's focus on this first. Now we're transforming from here over to here. So we got x inside the parentheses here, and over here we have 1 minus 2x. Now, just so that you don't confuse that this x here is the same as this x, what the book uses is they refer to this as a. So they refer to that as f of a. And they leave this as x. Now we still got this that we're transforming to this. So basically we're setting a equal 1 minus 2x. And so we go up to each one of our points up here, and the a is the first part of our point, the x part. So what we're going to do is, like for our first point here, we'll set the -4 equals 1 minus 2x, and then we'll solve for x. So take -2x that side, -4 over here. We get 2x is equal to 5, or x is equal to 5/2. Okay. Now this is the x that's referred to over in this function. So we can find g of 5/2, and we'll go through and plug 5/2 in. So we got 4 minus 3 f of 1 minus 2 times 5/2 all over 2. So then we got 4 minus 3 f of 2 times 5/2, the 2's cancel. We got 1 minus 5, which is -4 over 2. Now f of -4, I'm wondering, well, what in the world is f of -4 equal to? To understand this, f of -4 is equal to something. Whatever's inside of our parentheses is our x, and the other side is our y. So we're looking for a point that starts with -4, comma something. Well, that's pretty easy. Our first point here is -4, -3. Which means that what we're looking for is the -3. So down here, we're going to have 4 minus 3 times -3 over 2. Now -3 times -3 is 9, so we got 4 plus 9, which is 13 over 2. So the point on our transformed graph will be 5/2, 13/2. Okay, so that's for our first point here. That's the transformation of this one here. Now the transformation of our second point, and I'll just do a few of these so you see the general idea. Now again, we're going to set the a, which is -2, equal to 1 minus 2x. Take -2x over here, becomes a positive 2x. Take -2 over there, becomes a positive 2. 1 plus 2 is 3, so that's going to give us x is equal to 3/2. Now again, this x we just found here is the new x that goes into our g of x. So we're going to have g of 3/2 equals 4 minus 3 f of 1 minus 2 times 3/2 all over 2. So we got 4 minus 3. These 2's cancel, so I got 1 minus 3, which is -2 all over 2. So we want to find f of -2. So we're trying to find something. So it's blank. Now what's inside of our parentheses are our x, so they're telling us x is -2, and this is going to be y. So we're looking for a point on our graph that starts with -2 comma something. Well, -2, 0, and all they're wanting is the 0, so that's going to be equal to 0. So if I come back down here, this is going to be 4 minus 3 times 0 over 2. 3 times 0 is 0, so it drops away. 4 divided by 2 is 2. So this point, transformed, is 3/2, comma 2. Now one more. Let's take a look at this one, transformed. Okay, so I'm going to set a, which is 0, equal to 1 minus 2x. Take -2x over, it becomes a positive 2x, and we get x is equal to 1/2. So then, that's our transform value for x. So we're going to plug that into our g of x. So g of 1/2 is equal to 4 minus 3 f of 1 minus 2 times 1/2 over 2. Well, 2 times 1/2 is 1. 1 minus 1 is 0. So we got f of 0 over 2. Now again, we're trying to find f of 0 is equal to something. And whatever's inside of your parentheses, your x, and then this side is your y. So we're looking for a point on a graph that's 0 comma something. You've probably seen a pattern, aren't you? 0 comma 3. Notice how these are always giving us the y part of our point. That simplifies the calculations. Okay, so 4 minus 3, and what would we say that was? 3 divided by 2. 3 times 3 is 9. 4 minus 9 is -5, so we got -5/2. So this point will be 1/2, -5/2. Now if I continued for the other 2 points, then what I do is I plot these points, and that'll be the graph transformed. Now it's kind of strange. It's not the usual way we see transformations done, but you'll always do that whenever you just have a x here, and then you're transforming it with something other than an x over here. Of course, the key is that this says f of, and this says f of. That's why you set them equal to each other.